Imagine a fingerprint scanner unlocking a secure door, but instead of recognizing the authorized user, it lets someone else in. Sounds scary, right? This situation is exactly what cybersecurity professionals call a false acceptance, and understanding it is critical when designing biometric security systems. Before we dive deeper, if you're learning cybersecurity or preparing for Security Plus, like, subscribe, share, and comment for more quick lessons from learning computer science with Leah. In biometric authentication, systems compare a new biometric scan, like a fingerprint or face, to a stored template in a database. But because biometric data is based on real-world measurements, it's never perfectly identical every time. That's where the false acceptance rate, or FAR, comes in. FAR represents the probability that the system incorrectly identifies a match between the biometric input and a stored template. In simple terms, someone who should not be allowed in is mistakenly authenticated. This happens because biometric systems rely on threshold values. A threshold determines how similar two biometric measurements must be before the system says, yes, this is the same person. Here's the challenge for system designers. If the threshold is too low, the system becomes more forgiving, which means more false acceptances. But if the threshold is too high, the system becomes stricter, which reduces false positives but increases false rejections, where legitimate users get denied. So security teams must carefully balance these two outcomes. In cybersecurity, a false acceptance is usually considered worse than a false rejection. After all, it's better to make a legitimate user try again than to let an attacker into the system. That's why tuning biometric thresholds correctly is essential for secure authentication. If this helped you understand biometric security concepts, like, subscribe, share, and comment for more cybersecurity insights and exam tips.